Hello everyone, welcome back to Math Hands-On with Python class, and today we are going to wind up our discussion on project management by looking on the project evaluation and review technique, in short PERT. So let's see what is the project evaluation and review technique is. So the project evaluation and review techniques, or PERT, is a tool that helps a project manager in project planning and control. So it is basically a method for analyzing the task involved in completing a given project, especially the time needed to complete each task and identify the minimum time needed to complete the total projects. Now, we have a basic assumption in project evaluation and review technique. So in PERT, or in project evaluation and review technique, we assume that it is not possible to have precise time estimate for each activity, and instead a probabilistic estimates of time alone are possible. So remember, in critical path method, the assumptions which lead us into CPM, we assume that it is possible to have precise time for each activities involved in a project. Now, let's see how we can determine the PERT while we don't have a precise time. Okay, so PERT is a 3-point activity estimating technique that consider estimation, uncertainty, and risk by using 3 estimates to define and approximate probability for activities, cost, or duration. And the 3 estimates used in project evaluation and review techniques are the optimistic time, or T0, and this optimistic time is the minimum time required for an activity to be completed. And we have the most likely time, or TM. So the most likely time is the average time that is assumed for an activity to be completed. And the third information is the pessimistic time, or TP. A pessimistic time, we say, is a maximum time that is assumed for an activity to be completed. So these 3 informations are the basic informations for a project evaluation and review technique. So we are going to use these informations in project evaluation and review techniques together with other methods. PERT involves statistical methods like computation of expected time for each activity. Remember, we don't have a precise time. Also, we have 3 estimates of time: the optimistic, most likely, and the pessimistic. So we need to compute a time estimate, which basically is an average of the given 3 time. Okay, so we are going to compute the expected time for each activity, and that expected time is computed from this formula, that is the sum of the optimistic time plus 4 times the most likely time plus pessimistic time divided by 6. And after computation of expected time, also in PERT we are going to compute the variance for each activity, and the variance for each activity is given by this formula, is a square of the difference between pessimistic time and optimistic time divided by 6. After computation of variance for each activity, then we need to compute the standard normal variant. The standard normal variant Z0 is computed from the desired completion value of time minus expected time for a critical path divided by the square root of the sum of the variances for the critical activities. And lastly, we are going to compute a probability for expected completion time as probability of Z less than Z0. So these are the basic statistical methods which are inculcated in PERT so that to estimate the total project completion time. Now, we are going to see how we can perform this project evaluation and review technique using the illustrative example. So let's consider this example here. The following table shows a list of tasks to be performed for completion of a project whose time estimate are given. So what is the probability of completing the project in the 35th weeks? Okay, now we have a table here, the table with activities, and we have a column for predecessors and the time estimate. So we have 3 time estimates, that is optimistic time, most likely time, and the pessimistic time. So to perform the project evaluation technique, we need also to have the network diagram. So in order to have the network diagram, we need to have single time information for each activity. But here you can see we have 3 time estimates. So we are needed first to compute for the estimated time for completion of each activity, and those estimated time are going to be used for drawing of a network diagram for our project. So this is the table which we are going to add 2 columns information, which the first one is for expected time and the second one is for variance. So for the time being, we need the expected time so that we can go and draw the network diagram. After drawing the network diagram, we will need the variance column. So the variance column will be used after having the network diagram. So let's start. So we are going to compute the expected time for completion of each activity. And the expected time is you take the optimistic time plus 4 times most likely times and plus pessimistic time divided by 6. So you take this information and feed into your formula, and then you will end up with this column here. And also you go to the column of variance, you take the difference between pessimistic and optimistic time, you divide by 6, you square it, you get the variance for each activity. And this is the values that you can obtain from the variance of each activity. Now we have the table with the 2 informations which will be useful for the other steps. So we are going to use the expected completion time to draw a network diagram for our project. And the project diagram for this one is as follows. You can see this is the network diagram. Remember, activity A has no predecessor, and activity B and C, its predecessors is activity A, and activity D, its predecessor is activity B. Activity E, its predecessor are activity C and D. Activity F also, its predecessor are activity C and D. Activity F here, we connect to E with dummy activity because activity F is not connected to activity E except it is connected to activity D and C. So once D and C completes, then we perform activity F. So this information which will come to activity F will come directly from activity D and C, not for E. And the predecessor for activity G is activity E and F. So this is the network diagram. So filling the information, we have the expected completion time. So the expected completion time for each activities, we locate them, and these are expected completion time which we computed. So now let's perform the forward and backward method for computing the early time and late time. So we start with the forward method. We compute the early time. So the early start time of activity A, basically we set it equal to 0, and its early finish time, you take the early start time plus duration, then you get the early finish time. So this, you follow the table which you can see here to compute for the early start time and the early finish time. So the next box, which is activity B, its early start time is 21, and its early finish time is going to be 21 plus 5, which is 26. And for activity C, its early start time is the early finish time of activity A, which is 21. And we plus 7, we get to 28. For activity D, we are going to have 26 plus 2, 28. Activity E, we are going to have the early start time here is the maximum finish time between these two, but the maximum finish time is equal, so it's 28 plus 5, we get 33. Then for activity F, remember, is not connected directly from activity E, except it starts immediately after completion of activity C and D. If so, then it's the early start time is a maximum early finish time between the early finish time of C and D. So, and the early finish time for the activity C and D, the maximum one is 28, and now we are going to have 28 plus 8, we are going to have 36. and the early start time of activity G is the maximum early finish time between activity E and F, and the maximum finish time between activity E and F is 36. So we are going to have 36, and its early finish time is 38. So we are done with the earliest time computation using the forward method. Now we are using backward method to compute the late time. So the late finish time, basically we set it equal to the early finish time. So the late finish time is equal to early finish time, which is 38. Then the latest start time, okay, the latest start time is the difference between the late finish and the duration, and we are going to have 36. And the float is the difference between the late finish minus the early finish, and that gives us 0. So for these two activity, okay, both of them, they share the common node. So the early finish time for activity F and the E is 36. So both of them, they are going to have 36, and for activity E also is going to have a late finish time of 36. So let's begin with the activity F, where we have now this late finish time 36. So the latest start time is going to be the 36 minus 8, and we are going to have 28. And the float here, we have 36 minus 36, which is 0. So we go to activity E. Remember, I told that both of these, they come from the same activity, so their late finish are equal or the same. So the late finish of activity E also is 36, and the latest start is going to be the difference between 36 and 5, and there we are going to have 31, and the float is the difference between 36 and 33, which is 3. So we go to activity C and D. Activity C and D, they meet at two activity, okay? So this activity C and D, they meet at two activity E and activity F. So if both of them, they have two common nodes, so the late finish of these two activities C and D, okay, is the minimum late start of the activity E and F. So the minimum late start between activity E and F is 28. That means at activity D, we are going to have 28, and also at activity C, we are going to have 28. So late start for activity D is going to be the difference between 28 and 2, that is 26, and the float is 0. For activity C, the difference is 27 minus 28 minus 7, we are going to have 21, and the float is 0. And also after activity C, we go to activity B, where the late finish is the late start of the previous activity, and there we are going to have 26. 26 minus 5, we get 21, and the float is 0. And at activity A, the late finish is the minimum late start between activity B and C. So the late start here is the same, 21 and 21. That means the late finish at activity A is going to be 21, and the late start is the 0, and the float is 0. So we are done with the network diagram. Now we're supposed to determine the critical path. That is next step in the PERT. So the critical path basically is formed by critical activities, and the critical activities are those activities with 0 float. So you can see activity A have a 0 float, activity B have a 0 float, activity D have a 0 float, activity F have a 0 float, G have a 0 float, C have a 0 float. So it seems like we have two critical paths. So you can go from A to B, B to D, then D to F. Remember, F is connected to D and C, but not to E. So if after D, you can go to F, and F to G, or you can go the other way, A to C, and then C to F, and from F to G. Okay, so we have two kind of critical path. So these are A to B, B to D, D to F, F to G, and the other one is A to C, C to F, and F to G. So these are the critical activities which form a 38 weeks of completion of the project. So after having the critical path, we see that we have two critical paths. And the decision now is become harder because we would like to estimate the project completion time for a single critical path. Okay? So how can we decide if we have two critical paths? That is a challenge. But this challenge is very easy. What we do, we need to choose the critical path whose total variance of its activity is larger than the other. So now let's see how we can obtain those information. So for critical path A, C, F, and G, the total variance is obtaining by taking the sum of variance of each critical activity. And this critical path is formed by critical activity A, C, F, and G. That means we are going to add or to sum the variance for activity A, C, F, and G. And that is, we are going to have 9 plus 2.778 plus that one and plus 0. And the total variance for critical path A, C, F, G is going to be 11.889. So the variance for the critical path A, B, D, F, and G now is going to be the total of variance for the activities forming the critical path. So that means we are going to have 9 plus 1 plus 0.11 plus 0.11 plus 0, and that means we are going to have 10.222. Therefore, the variance for activities A, C, F, and G, which forms the critical path A, C, F, G, will be used in determining the project completion time. Okay, so after having the critical path, which we are going to use it in projection for completion of the project, now let's compute the normal variate. Okay, so the normal variate is given by the desired completion value of time minus the expected time in a critical path divided by the square root of the sum of variances in the critical activities. Remember, we are going to project the chance of completing the project within 35 weeks. And that is the desired completion time, which is 35 weeks. And the expected completion time, we computed it, and this expected completion time is for critical path. So the critical path have a total of 38 weeks. And this sum of the variance for critical activities we computed in the previous slide, which is 11.889. So we are going to compute the variate, the Z naught, and the variate is the difference between 35 minus 38 divided by square root of the variance, and this one will give us the minus 0.87. So after having the normal variant, we are going to conclude the PERT by computing the probability of completion of the project within 35 weeks. So, and this one is basically computed or determining by reading or by computing using scientific calculator the probability of Z less than minus 0.87. And the probability of Z less than minus 0.87 basically is to the left of the probability distribution. Now we are going to read the coefficient of this probability from the negative Z-score. So we have a part of negative Z-score table, and we are going to read this coefficient by splitting it into two parts. The first part will be minus 0.8, and the second part will be 0.07. So the minus 0.8 is going to be read from the Z column, and from this Z column we go down there and we look for minus 0.8, and the minus 0.8 is there, and then we go to a column where we have the 0.07 horizontally from this row here, and we find for 0.07. So a coefficient corresponding to the probability of minus 0.8 will be the intersection reading between the minus 0.8 and 0.07, and that coefficient is going to be 0.1922. So this coefficient basically is the coefficient for the probability of z less than minus 0.87. So what does it imply now for this coefficient? This means that the project has only 19% chance of being completed within 35 weeks. Therefore, this is how we can perform the project evaluation and review technique. So go through other questions, make practice on how you can predict project completion using PERT technique. So thank you for watching. Don't forget to subscribe, like, comment, and share the content of this video. Thank you. Until next time, goodbye.